This is Lab Group Zeta's project for ENSC100, the showermometer.
My name is Cyrus and I worked on the motor codes.
John Sear, probe code and research.
My name is Justin Veer, oral presentation, poster, and gear designs.
Wonga, I did the brainstorming and the temperature probe coding.
My name is Brian. I worked on the main assembly and design for this project.
Nabiha Viva, and I worked on the design process.
My name is Graham, and I helped code the probe for a project and testing and troubleshooting.
Hello, my name is Alex Tomasino, and I contributed to the gear and physical design for this project. The purpose of our design is to give the user a better shower or bath time experience. It was designed for shared bathroom spaces, such as in family or shared households and university dorms.
The showermometer uses a temperature probe to measure the temperature of the water, and the user can set their preferred temperature by pressing the button here. The user can press this to change the temperature to their preference when not at the desired temperature. This design helps eliminate any unnecessary discomfort caused by having to test the temperature yourself, where the user only needs to do it once to set the temperature.
Our design features three main parts: the probe, the electronics, and the gear motor system. The probe would be attached underneath the faucet to provide an accurate measurement of the water temperature, using duct tape or an alternative would work to attach the probe to the faucet.
Our electronic setup is what made everything work. We had our probe, which sent measurements to the Raspberry Pico board, and that internalized the measurements when the user would press the button.
The board connects to our motor controller, which dictates to the motor how much to turn to change the temperature. This is visualized by the red and green LEDs, where green tells the user when the temperature has been achieved and red when the temperature is being adjusted. The motor will continue to adjust automatically if the probe detects a variation greater than 1 degree Celsius.
So to test our original idea, we tested our project on the Lab 1 sink, determining if our base idea was to work properly. We could model it differently to account for different kind of shower knobs and faucet setups. The motor uses a 3D printed gear mechanism that is responsible for rotating the shower knob. We use the Cura slicer to design the parts, and the mechanism is attached to the back of the faucet spout. Our design also uses like a string with like a fitted grip that is attached to the tap handle.
Some of our design limitation was that our design is specifically made to be tested on the Lab 1 sink. As discussed in our group presentation, this was done to prove our idea would work with the assumption that the same technology can be applied to different sizes and shapes of shower systems.
Adding more lights or even an LED screen would enhance the user interface, improving the user experience using the showermometer. However, time was against us and we did not have enough time to create these solutions.